Let's work on understanding exponents a little bit better together. For problems 1 through 4, let's start by identifying the base and the exponent for each of the given powers. So for number 1, we're given 7 to the 5th power. That is our entire power. Our base here is going to be 7. 7 is going to be the base of this power, and our exponent here is going to be 5. So you can think of the big number as the base, and the exponent is the smaller number. Okay, so that little number 5 tells us how many 7s are multiplied together. For number 2, we have 3 to the 4th power. The base here is going to be 3, and our exponent here is going to be 4. So that means we have 4 of those 3's that would multiply together. For number 3, we have -8. That whole thing is being raised to the 9th power here. So the base here is going to be -8, and the exponent here is this +9. And for number 4, we have -15 raised to the 4th power. However, this one's a little different from number 3 because notice how there's no parentheses. So the base is actually just the 15, and then the exponent is the 4th power. So we would have 4 of these 15s multiplied together, and then we would take the opposite of that afterwards. So that negative has no effect really on the base, on the exponent, or the power. Okay, let's move on to the next set of problems here. So for these set of directions, we're going to go ahead and condense each of these multiplication sentences and write it as a power, and then we're going to identify the base and the exponent. So we don't have to solve anything here. All right, so for number 5, looks like we have 3 times 3 times 3 times 3 times 3 times 3. So by my count, that is 6 of them. So we could rewrite this as 3 to the 6th power, so a big 3 and a little 6. And the base here would be 3, and the exponent would be 6 here. Okay, so that would be the power, and that would be a pretty big number. For number 6, we have -8 times -8 times -8, so that is a repeated multiplication sentence. So if we're going to write this as a power, it's important to put the -8 in parentheses here, and that's going to be, there's 3 of them, so we raise that to the 3rd power. The base here is -8, and then the exponent would be 3. Okay. For number 7, we have half times a 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 half. So it looks like there are 6 of these here. So when we're writing the power, when we are given fractions, we really should put them in parentheses. So let's put 1/2 in parentheses, and there are 6 of them. So let's raise that to the 6th power. The base here would just be the fraction. So we can have fraction and decimal or rational bases as well as integer bases or whole number bases. The exponent here is going to be a 6 because there's 6 of those halves being multiplied together. For number 8, it looks like we have -3 tenths times -3 tenths times -3 tenths. So this power we would write, let's go ahead and put it in parentheses, give it a hug. So -3 over 10, it's that whole thing, and then there's 3 of these, okay? The base would be -3 tenths, that's the base of the power, and then the exponent here would be 3. All right, moving on to these next set of problems. Here what we're going to do is we're going to expand each of these powers. So we're going to be given powers, and we're going to go ahead and write the multiplication sentence. We do not need to evaluate these though. We're just going to go ahead and see what this represents. So for number 9, we have 3 to the 5th power. We're not going to go ahead and solve it, but as a multiplication sentence, this would be 3 times 3 times 3 times 3, and then 1 more. So there should be 5 of these 3's multiplied together. Okay, it's not 3 times 5, there are 5 of these 3's multiplied together. For number 10, we have -2 raised to the 8th power. So this would be -2, and I recommend using parentheses to show this. So -2 times -2 times -2, that's 3 of them. That's 4 -2's, that's 5 -2's, that's 6 -2's, that's 7 -2's, and that's 8. Okay, so we would multiply 8 of those -2's together. For number 11, we have the fraction -2/3, that whole thing raised to the 3rd power. Again, you should use multiplication here to show this, and we should also use parentheses. So let's use -2/3 inside this parentheses and multiply that by another -2/3, and let's multiply that by a third -2/3. So 3 of these fractions multiplied together here. Finally, for number 12, we have -2.5 raised to the 4th power, but notice how there are no parentheses here. So what's really being raised to the 4th power? It's not -2.5, it's just one of these 2.5. So we have a negative in front, and then we're going to have 2.5 multiplied by 2.5. That's 2 of them. Here's a 3rd one, and here is a 4th one. So be careful here. If the negative's not inside the parentheses, there's only one negative, and there are 4 positive 2.5s multiplied together. Now hopefully we understand exponents and powers just a little bit better. Let's go ahead and practice actually evaluating them or solving them. So for these next set of problems here, let's go ahead and evaluate each of these powers without using a calculator. Okay, so without, we want to try to do this by hand. And let's show our calculations as needed. All right, so for number 13, we have 4 to the third power. So that's really 4 times 4 times 4. All right, so 4 times 4 is equal to 16, and then 16 times 4. I'm going to go ahead and write out as many multiplication problems as I can here to be super clear in case anybody wants to see them. I'm assuming sometimes you might feel comfortable doing these in your head and sometimes you might not. So I'm just going to write it out just in case. 6 times 4 is 24, carry the 2. 4 times 1 is 4 plus 2 is 6. So this whole thing is going to equal 64. Okay. For number 14, we have 3 to the fourth power. So this is really 3 times 3 times 3 times 3. So that is 4 3's multiplied together. Now, here we can say, okay, 3 times 3 here, that does equal 9, right? And then 3 times 3, that does also equal 9. So 9 times 9, that should equal 81 if we go ahead and multiply those together. So let's go ahead and say that this is going to equal 81. And for these ones, I'll box the answers just so it's super clear. There's definitely a lot more work going on in these problems, okay? So again, 3 to the fourth power and 4 to the third power are not the same thing, so please be careful with that, okay? For number 15, we have this negative 2 raised to the fifth power. So that's really going to be negative 2 times negative 2 times negative 2. That's 3 of them. We have a fourth one and then a fifth one here. Now there are 5 negatives being multiplied together, so that's an odd number of negatives, so your answer is definitely going to be negative since 2 negatives will make a positive when we're multiplying. Now let's see what we have here. Now 2 times 2, that's going to be 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. So I'm going to go ahead and say this is going to be a negative 32. Okay, just again, there are 5 negatives here, and so 5 negatives has to give you a negative. All right, moving on to number 16. For number 16, we just have a positive 5 raised to the third power, so it's 5 times 5 times 5. Now let's see, 5 times 5, that's 25, right? But what's 25 times 5? So I'm going to go ahead and just write this out to be a little bit more clear. 5 times 5 is 25, carry the 2. 5 times 2 is 10 plus the 2, that's going to be 12. So this is going to be multiplied together to get 125. All right, that's what 5 to the third power is. And if you did it in your head, great. If you didn't, then that's fine. Just go ahead and multiply out using the standard algorithm. Now for number 17, we have 8 to the 0th power. And now something you want to know is that anything raised to the 0th power is always equal to 1. So this would be just equal to 1, okay? And if that feels a little bit strange, think about this perhaps. If you said something like 8 to the second power, that would equal 64, right? So then 8 to the first power, that equals 8. So what must 8 to the 0th power be? Well, if you notice here, the exponents are going down by 1 each time, but over here on the side, we are dividing by 8, right? So each time you lose a power or go down a power, this should be dividing by 8. So the only thing that makes sense here is going to be 1. And you're not going to learn about negative exponents right now, but 8 to the negative first power is actually just equal to 1/8 because that is what 1 divided by 8 is equal to. So hopefully that helps you make a little bit more sense, okay? Moving on to number 18, we have this negative 15 raised to the third power. So keep in mind, this is negative, but then there are 3 of these 15s multiplied together, okay? There's only 1 negative here, so our answer will be negative. Okay, now let's go ahead and figure out what 15 raised to the third power is, right? So we can start off by writing 15 times 15. Okay, so 15 times 15, that's going to be a 5, carry the 2. That's 5 times 1 is 5 plus 2 is 7. Then 1 times 5 is 5, 1 times 1 is 1. Let's go ahead and add these. That's going to be 5, that's 12, carry the 1, that's 225. Okay. Now let's take this 225 and multiply that by 15. Okay, so let's see, 5 times 5 is 25, carry the 2. 5 times 2 is 10 plus 2 is 12, carry the 1. 5 times 2 is 10 plus 1, that's 11. 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. If we add these up here, I'm getting a 5, a 7, a 3, and a 3. Okay, so let's see here. That's 15 times 225, 3375. I think that makes sense. Yeah. So let's go ahead and say that's going to be a negative 3,375, right? And that hopefully makes sense. It's negative because we had just one negative in our multiplication sentence, okay? Let's go ahead and check out number 19. For number 19, we have 4 of these 1/2s multiplied together. So we have 1/2 multiplied by 1/2. That's 2 of them. Now there are 3 of them, and now there are 4 of them. And they're all positive, so we don't have to worry about negatives here, okay? So let's see. Well, on the numerator side, 1 times 1 times 1 times 1, that's just going to be 1 on top. But what about the denominators? Well, 2 times 2, that's 4, times 2 is 8, times 2 is 16. So we're actually going to get a fraction here of 1/16. So if you take a half of a half of a half of a half, you actually have a 16th of what you started with, okay? For number 20, we have this fraction 3/5, and there are 3 of them. So let's take 3/5 multiplied by 3/5 multiplied by another 3/5 here. Okay, so let's see what's going on here. In the numerator, we have 3 times 3, that's going to be 9. And 9 times 3 is going to be 27, right? So 27 on top. And on the bottom, we have 5 times 5, which is 25. And then 25 times 5, I think we already did that earlier, right? 25 times 5 we said was 125. So let's go ahead and just use that over here and say that would be 125. Okay, so 3/5 of 3/5 of 3/5 would be 27 1/25. Let's check out number 21 here. For 21, we have this negative 7/2. We're going to go ahead and square that. So there's 2 of them. So it's a negative fraction multiplied by another negative fraction. So a negative times a negative is a positive, right? So let's see on top here, 7 times 7, that's going to be 49. So we can go ahead and put 49 on top. And on the bottom, 2 times 2 is 4. And so this we could write as our answer. Just a negative times a negative is a positive. You could also write this as a mixed number if you want. 4 would go into 49 12 times. So you could say this is 12¼ as well. So this would be the mixed number version if you needed to write that for a particular reason. Okay, let's move on to 22. For 22, we have a mixed number raised to the 3rd power. So let's go ahead and change this into an improper fraction. So 3 times 3 is 9. 9 plus 2 is going to be 11. So this is really 11/3 multiplied by 11/3 multiplied by another 11/3. All right, so we got a lot of multiplication that we have to do here. Now, if we have 11 and we're going to raise this to the 3rd power, let's see, 11 times 11, hopefully, well, if you don't know, it's going to be 121. So that's 121, that's 11 times 11. Let's multiply by another 11 though. Okay, so 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1, then 1 times 1, I guess it's going to be the same exact thing twice, right? So let's go ahead and see, that's going to be 1, 3, 3, 1. So on the top here, 11 times 11 times 11, the numerator is going to be 1,331. And what about the denominator? For the denominator, we have 3 times 3, which is 9. 9 times 3 is 27. So let's go ahead and just leave this as an improper fraction. Again, if you wanted a mixed number, feel free to do so, but you would just need to do some long division to get the mixed number. For number 23, we have 0.5 or a half squared. You could definitely do this as a fraction, but let's practice using our decimals as well. So 0.5, there's 2 of them, so it's 0.5 times 0.5. Let's see here, it's really just 5 times 5, right? 5 times 5, and that would be 25. But notice how there are 2 decimal places, so it looks like there's 1 decimal place here and a 2nd decimal place here, so we need to have 2 decimal places in our product. So a half of a half is a quarter, so hopefully that makes sense that we get 0.25 or 25/100ths for this answer. Okay, same thing, fraction or decimal, a quarter or 1/4. All right, for number 24, looks like we have a negative decimal here. So let's go ahead and take this negative 0.8 or negative 0.8. Just we'll save a little bit of writing here. Negative 0.8, and a third negative 0.8. Okay, so what's 8 times 8? Well, 8 times 8 is going to be 64. And what's 64 times 8? So let's go ahead and take 64 and then multiply that by 8. That's going to be 8 times 4 is 32. Carry the 3. 6 times 8 is 48, plus 3 is going to be 512. Now, how many decimal places are we going to have here? Well, looks like we have 1 decimal place, 2 decimal places, and 3 decimal places. So it looks like we should have 3 in our answer here. So I'm thinking here that we should have 0.512 or 512 thousandths. That would be the answer or the value of this power. Keep in mind that there are 3 negatives, so 1, 2, 3 negatives. So if there's an odd number of negatives, we should have a negative 0.512 for our value of this power. For number 25, we have a negative decimal here, so negative 2.4. We're multiplying that by itself, so we have 2 of these, so 2 negatives multiply to get a positive. So really we have 2.4, and we're multiplying that by 2.4. So really that's just 24 times 24, right? So 24 times 24, and then we'll deal with the decimals in just a moment. 4 times 4 is 16, carry the 1. 4 times 2 is 8 plus 1, that's going to be 9. 2 times 4 is 8, and then 2 times 2 is 4. Let's go ahead and add these together. 6 comes down, 9 plus 8 is 17, carry the 1. 1 plus 4 is 5, so we have 576. So we just figured out that 2.4 times 2.4, or 24 times 24 is 576. Looks like we have 1 decimal place and 2 decimal places, so logically we should have 2 decimal places in our answer here. So let's go ahead and say a negative times a negative is a positive. So we should have positive 5.76. This would be the value of this power. All right, here is number 26. Now number 26, keep in mind this one is very similar to another one we had done for number 17. So that's raised to the 0th power. So these ones hopefully you like, because anything raised to the 0th power is equal to 1. So 4.5, even a decimal, raised to the 0th power is equal to 1. All right, so that one's nice, short, and sweet. For number 27, we have this 3/4, and it's negative, but the negative's on the outside, so we really have a negative, and then we have 3/4 being multiplied by another 3/4 here, okay? So let's deal with the negative afterwards. Let's just go ahead and do 3 times 3, that's going to be 9 for the numerator. And then in the denominator, 4 times 4 is 16. And then we have a negative that's in front, because that just means the opposite of whatever we get. So that's going to be negative 9 over 16, okay? Now, if the negative was on the inside, we'd have a negative 3/4 times a negative 3/4, and that would be a positive 9/16. And that's if that we had that, but we don't. So in this case, it would be a negative 9/16. Okay, so for number 28, and this one's actually kind of what I was just mentioning. This one, the negative is on the inside, so it's negative 2/5 multiplied by another negative 2/5. So it's a negative times a negative, so this one will be a positive. On top, 2 times 2 is going to be 4, so the numerator is going to be a 4. And on bottom, a 5 times 5 is 25. So a negative times a negative is a positive, so we have 4 over 25. For number 29, we have negative 2 raised to the 4th power, so we do have a negative, and we have a 2 times 2 times 2 times 2. Keep in mind that negative does not apply to all the 2's, okay, just the first one. So 2 times 2, that's going to be 4. 4 times 2 is 8. 8 times 2 is 16. Because we had 1 negative in the problem, that's negative 16. So that's what negative 2 raised to the 4th power is if there's no parentheses. Okay. Finally, we have number 30. Number 30, we have this negative 7. This negative 7, there are 4 of them, so we should go ahead and group them like this and show that there are 4 of these negative 7s. That's 3, and then that is 4. Now, a negative 7 times a negative 7, that's a positive 49. And then let's see, a negative 7 times another negative 7 is another positive 49. So really, we have to figure out what 49 times 49 is, okay? So let's see here. I'll write that underneath. Over to the side here, 49 times 49. 9 times 9 is 81, carry the 8. 9 times 4 is 36, plus the 8, that's 44. So 441 for our first partial product. 4 times 9 is 36, carry the 3. 4 times 4 is 16, plus 3 is 19. Let's go ahead and add these up here. So 1, 4 plus 6 is 10, carry the 1. That's 14, carry the 1. That should be 2,401. So looks like we had 4 negatives, so a negative times a negative times a negative times a negative, which we got a positive times a positive, which is still positive. And so this whole thing would be equal to 2,401. That would be the value of this power. Alrighty, so there you have 30 different practice problems, hopefully helping you feel more comfortable with how powers work. They have a base and an exponent, and make sure that you know how to expand them and also know when you have negatives versus when you have positives. So those integer rules hopefully help you out a little bit there. All right, so hopefully you found this video helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.